All right, well, today's objective, I can solve and graph one variable inequalities. And yesterday, we already started 2 days ago with inequalities by graphing and looking for solution sets. Yesterday, we started with addition and subtraction. Today, we're going to continue with multiplication and division. We know what one variable inequalities are, so you already have definitions, examples, unexamples, and we know that they have inequality symbols, one variable or one unknown, and the variable cannot have x1 is greater than 1. Our steps, once again, simplify, isolate, plot, and check. We're going to continue using those. So, just to reemphasize, we said for yesterday or the previous lesson, we said whenever we add something to the inequality to each side, it's addition property of inequality or subtraction property of inequality. If we subtract today, since we're multiplying and dividing, of course, we have multiplication properties of inequality if we multiply to each side of the inequality. If we divide to each side of the inequality, it's division property of inequality. Okay? So just to note that, we're going to use those as we continue. So copy this example down, example 1. Solve the inequality and graph the solutions. 7x greater than negative 42. All right? So to start solving for this, and we know that the process is the same as equations. So here we go ahead and divide by 7. Since the 7 is multiplying the x, the inverse is to divide by 7. So 7 divided by 7 is 1. We're left with x is greater than negative 6. So let's see, step 1, simplify. We couldn't simplify both sides, so we went straight to isolation. We leave the x by itself by using inverse operation. So step 3 is plot our solution. So I'm going to go ahead and get a number line going right here. We have 0. Negative 6. And since this inequality symbol does not have the equal sign underneath, therefore I'm just going to label my spot with an open circle. All right? So, with that said, let's read this. It says x is greater than negative 6. So what number can I substitute here for x that would make it greater than negative 6? So let's see. Any number on the number line that makes it greater than negative 6? That is correct. Everything to the right. Negative 5, negative 4, negative 3, 2, 1, 0, and everything that way. So, we're going to shade everything to the right. So in that way. And at the end, we're going to write an arrow indicating that it continues. Okay? So, let's see. Simplify, isolate, plot, and our last step is check. So let's check this. I'm going to rewrite this inequality. 7, open parentheses for the variable, greater than negative 42. So now, we're going to substitute our dividing point, negative 6. Let's see. 7 times negative 6, that's negative 42. And I bring the rest down. Greater than negative 42. So let's see. Is negative 42 greater than negative 42? No. This is false. It's not true. False. So you're saying, well, Mr. Kivin, why do we use this number? Well, we use it because that's where our solution set starts. But notice that we did not shade in that circle. Everybody see that? Yeah, what does that mean? That our solution set, all these numbers to the right are solutions that would make this true, except for which point? That's right, negative 6. Negative 6 cannot be part of the solution. But this, when we graph it, it indicates where we begin our solution set. That's why when we substitute negative 6 in here, this is false. It doesn't work. But what if I substitute any other number that's on this side? Let's see if it works. I'm going to rewrite that. 7, open parentheses, greater than negative 42. And a number anywhere over over here. As a matter of fact, I'll use 0. 0. What is 7 times 0? 0. I bring everything else down. Greater than negative 42. So let's see. Let's read this. 0 is greater than negative 42. Is that true? Yes, we know that all the negative numbers are less than 0, or any positive number is greater than negatives, right? So therefore, 0 is greater than negative 42. That is correct. And you see, this is just to let you know that whenever we graph and we leave this point an open circle because it doesn't have the equal sign right underneath the inequality, that tells us that we do not include that point in our solution set, okay? So now how would we write our solution set? If this was our solution right here, our solution set will look something like this. I'm going to do that in blue. The set of all x such that, what is our inequality? X is greater than negative 6. And this is our solution set. Okay? All right, let's continue. Copy this next example. All right, example 2, if you want to call it 2. Let me rewrite this right here. Example 2. And it says, solve the inequality and graph the solutions. We have 3/4 are less than 12. Okay, let's solve that. Now, let me show you first if we do this step by step. The 3/4 is multiplying the variable r. So in order to undo the multiplication, we need to divide by 3/4. And whatever we do to one side, we do to the other side. So 3/4 divided by 3/4, that's 1. 1 times r is r. Less than, let's see, what do we get here? This becomes 12 over 1. Let me rewrite this over here so you can see it. This is 12 over 1 multiply times the reciprocal, which is 4 over 3. So if we multiply this out, we get 48 divided by 3, because 1 times 3 is 3. Therefore, this is 16, so this is 16. So far, so good, right? So now, we can do that, or we can use the shortcut. Here goes the shortcut. Once again, example 2. Let me show you the shortcut. Instead of doing the full step, here we know that at the end of it all, here we're going to have to multiply times the reciprocal. So check this out. If I multiply times the reciprocal right here, what is 4 times 3? That's right, 12. And 3 times 4, 12. So what is 12 divided by 12? Yep, it's 1. We know that this is 1. So what is 1 times r? R. And whatever we did to one side, we need to do to the other side. So I need to multiply this side times the reciprocal of 3/4, which is 4 over 3. So let's see. Does this look the same as what we did earlier? Yeah. So let's see. 4 times 12, that's 48. 1 times 3 is 3. So 48 divided by 3, that's 16. Okay. Simplify, isolate. Now we need to plot our solution. So we got 0. 16 is it about right here? Okay. So now, does this tell us, does it have a little equal sign? No. So therefore, for this one, we're just going to circle our spot, and let's read this. It says, r is less than 16. What number can I substitute for r that would make this true? Let's listen. R is less than 16. What number could be less than 16? Yeah, the next one down to the left. 15. How about 15.75? Yeah, anything below 16. So I'm going to say if I was to substitute 16, yes, and that makes it true. I mean, not 16, 15. However, so we got our solution there. So that means we're saying that any number to this side, if I was to substitute 0, 0 is less than 16, anything to the left. So that means I'm going to shade everything to the left with an arrow indicating the continues. Now let's test our point. I'm going to rewrite the equation I'm going to rewrite the equation, and it's 3/4, and instead of r, I'm going to write a parentheses, less than 12. So what number am I substituting in here? Well, according to us, it's 16. That's our dividing point. Let's see, 16. So let's multiply 16 over 1. 16 times 3, that's 48. Divided by 4 times 1 is 4. What is 48 divided by 4? That's 16. What did I write? 12 there. Sorry. This is 16. All right, so is 16 less than 16? No, that's false. And does that confirm what we did? Yes, we left this open, indicating that we are not including this one. But anything before that is a solution set. So which number would you like to test? Yeah, you can choose anything. I'll choose, I'm just going to use 0, because it's right there and it's just easy to substitute. I'm going to rewrite this. This is 3/4 parentheses, which is indicating multiplication, less than 16. So now I'm going to substitute this 0, because 0 is part of the solution set. Is that correct? Yeah. So what is 3/4 times 0? 0 is 0 less than 16. Yes, that's true. So let's write our solution set. I'm going to write it with blue. The set of all x such that, and what was our solution? Here's our inequality, such that r, oh, it's r. The set of all r's such that r is less than 16. Okay? And we're done. Okay, so now, multiplication and division, same process as equations. We just need to indicate our solution set with our graph. Okay? All right, now check this out. Let me go to this next slide. Copy this one down, please. And it says, solve the inequality and graph the solution. This is example 2A. 2A. So now, if I was to use, let me see, give me a second. All right, let's solve this. So, our first step, to leave x by itself, let's step 1. Simplify. Can we simplify any side? No, it's already simplified. Step 2, isolate. We need to leave the x by itself using numbers operations. So the negative 12 is multiplying. The inverse is to divide by negative 12. Both sides. Divide by negative 12 both sides. Let's see. Negative 12 divided by negative 12 is 1. 1 times x is x. So we're left with x less than negative 7. Think about it. What did you just notice right now? Yep. Did everybody notice that we flipped the inequality symbol? Yes, we did. So what does that mean? It means that since I went ahead and divided by a negative number, I had to flip the symbol to its opposite direction. So make a note for yourself. Put a note next to this problem and write, when multiplying or dividing by a negative number, multiplying or dividing by a negative number, you flip the inequality symbol. you flip the inequality symbol. When multiplying or dividing by a negative number, you flip the inequality symbol. Okay? And the rest of the process is the same. The only thing that you need to remember for division and multiplication, whenever dividing or multiplying by a negative number, we have to flip the inequality symbol. So let's finish this problem. We need to plot our solution. So here's my number line. 0, -7 is over here. And let's see. It says x is less than -7. What number can I substitute for x that will be less than -7? Right, -6, -5, everything this way, which means I need to highlight or shade everything this way. Now, does it include the point -7? Let's see. Let's look at it in inequality. Does it have the equal sign? No. So here we only circle the spot and make sure from there you shade everything to the left. Okay, everything to the left. I know, doing some weird stuff. So from there, the last step is to check. Let's rewrite our inequality. We have -12, open parentheses, greater than 84. Now, just to refreshing your memory, what's going to happen if I substitute this number right here into here? If I substitute -7, let's do that just so you can see it. -7. What is -7 times -12? That's right, 84. And 84, is 84 greater than 84? No, it's not true. And you know why it's not true? Because we have the open circle and we do not include this point. So what other point would you like to test from this section here? Okay, -10. Yeah, -10 is about right here. Right? Right, -10. So let's do that. I'm going to rewrite this, -12, open parentheses, greater than 84. And we're going to substitute in there -10. So what is -12 times -10? Right? That's positive 120. Is positive 120 greater than 84? Oh, that is correct. So, homework. Homework for tonight, page 151. Numbers 1 through 35. Odd. All right, guys. Well, and that's it. Just make sure, just don't forget that when you're multiplying and dividing by a negative number, you flip the symbol. Okay? All right, guys. Talk to you guys tomorrow. Enjoy your homework. All right. See you tomorrow.